Okay, so we're going to go through and do some practice problems through each chapter. I'm going to start out with doing some factoring. So we need to have some problems here. Okay, so I'm going to factor. Now on page, I believe it is 90, no, on page 70, we did some practice problems from the last section of the book. And you guys also had some strategies there listed. What we're going to do is practice factoring problems like this: x squared plus 9x plus 18. So I want factors of 18 that are going to add to 9. So I'm going to have 1 and 18, 2 and 9, and 3 and 6. Well, 3 and 6 add to 9, so I am going to use those as my factors. So, So I know that x plus 3 times x plus 6 would give me that trinomial. And I can check that by foiling back. First, outer, inner, last. So then I have x squared, combine like terms, and I'm back where I started. So factoring gives me this answer here. Okay, next let's try 4y squared minus 11y plus 6. This is where I'm going to use that gross product method, where I multiply a and c together first. So 4 times 6 gives me 24. So then I'm going to figure out factors of 24 that could add to a negative 11. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. Those are all my factors. A negative 3 and a negative 8 will add to negative 11. So what I'm going to do is have 4y squared, a 6, and then separate the negative 11 into the negative 3y and negative 8y. Now I'm going to group, because I have 4 terms, and I'm going to pull out a GCF from each group. GCF is greatest common factor, so I'm going to divide that out here. So notice here the only common factor here is a y. That leaves me with 4y minus 3. Then I'm going to pull out here a negative 2. That leaves me with a positive 4y minus 3. Now because I have the same thing in my parentheses, I have y minus 2 that I can bring together, and then 4y minus 3. And this is that trinomial fully factored, so this is my answer. Now, if you need to go back over that, just pause the video and go back through each step to see what I did. Now, let's try another one. I'm going to try one with that's a special case here. We have x squared minus 81. This is a difference of squares. So if I have something like x squared minus y squared, that's going to give me x plus y and x minus y. I get that by square rooting each one of these. So notice x squared is a perfect square and 81 is a perfect square. So x plus 9 and x minus 9 are going to be my factors here. Let's try a more difficult one. Let's try 25z squared minus 36y squared. We know this is a difference of squares because we are subtracting and both of these are perfect squares. So the square root of 25z squared, square root of 25 is 5, square root of z squared is 5z. Square root of 36y squared is 6y. So I'm going to have 5z plus 6y and 5z minus 6y. And that is fully factored. Okay? I also have problems where I could have something like this, x cubed minus 8. This is a difference of cubes. So what we use is called SOPUS. Now, first I have to get the binomial here. This is if I have x cubed minus y cubed, this is going to be x minus y times x squared plus xy plus y squared. Now, how we get that is using SOPUS. X minus y is the cube root of each of these, so that's going to be x minus 2. And SOPUS gives me the trinomial. So to get the trinomial part here, I'm going to have square the first, so square this x, opposite sign, so the opposite of a negative is a positive, product means to multiply these two together, always a plus, and then s is square the last. So this x minus 2 times x squared plus 2x plus 4 is my answer. And whenever I do a difference of cubes, this is always prime. That means it cannot be factored anymore. Now what if I have x cubed plus 8? How is that going to be different? Well, this was a difference of cubes because I was subtracting. This is a sum of cubes. So I'm still going to have x and a 2, but now I'm adding inside that binomial. And I'm still going to use SOPUS. Now, square the first, opposite sign, product, always a plus, and square the last. So here is that expression completely factored. All right, what if I have a more difficult one? For example, if I have 8x cubed minus 27. 8 is 2 cubed, 27 is 3 cubed. So I know I have a difference of cubes here. So I've got to find the cube root. Cube root of 8x cubed is 2x. Cube root of 27, negative 27 is a negative 3. Now I use SOPUS to give me that trinomial. So square the first. Now when I square this, sorry, let me redo that. When I square this first term, this is 2x squared. So I have to square the 2 and square the x. So my first term here is a 4x squared. My next is opposite sign for my O. This is a negative, so I'm going to have a plus. The product of 3 and 2x is 6x. Always a plus for the A. And square the last. So here are my factors for this. Okay. Next, I want to talk about the cost and revenue functions. Well, let me back up a little bit, and I'm going to actually do inequalities. So what if I have an inequality like this? The x minus 4 is less than 3. Okay? I'm just going to solve this inequality just like I would an equation. So this is going to be adding 4, so x is less than 7. You need to know how to plot those on the number line. X less than 7 means I have an open circle at 7 and I shade to the left. Now what if I have a problem like this? If I have 12z greater than or equal to negative 5z minus 7. Still going to add here, so I'm going to have, well, let me change this to a positive so it comes out even. I'm going to subtract that, so it's 7z greater than or equal to negative 7. I'm going to divide by 7, so z is going to be greater than or equal to negative 1. To plot that on the number line, I'm going to go to negative 1. It's going to be a closed circle because I have equal to, and it's greater than, so I shade to the right. Okay, next, what if I have 3 minus 2a is less than or equal to 15? I'm going to subtract 3 from both sides. So I have a negative 2a is less than or equal to 12. Here I'm dividing by a negative 2. And so when I'm dividing by a negative or multiplying by a negative, that means that I have to switch my inequality. So a is going to be greater than or equal to a negative 6. Now when I plot that on the number line, I have negative 6. A is greater than or equal to, and so I plot or shade to the right. Now what if I have an absolute value? So let's start with absolute value of b is less than or equal to 8. What absolute value means is that my distance of this quantity is less than or equal to 8 units. Well, the distance from this quantity, or the distance of this quantity from 0 has to be less than or equal to 8. Well, the distance from 0 to 8 here is 8 units, but we'll also have negative 8, that would be 8 units from 0 here. So what this is essentially saying is that b has to be less than 8 because the distance would be less than 8 units here, and I would shade to the left. Or for my distance to be less than 8 units here, I would shade greater than or equal to negative 8. So I have these two inequalities. So what I did is I dropped the absolute value bars and just kept it the same, b less than or equal to 8. And then the other one, I switched the inequality and made the value negative. So for example, if I have 3z minus 5 in absolute value bars plus 2 greater than or equal to 10, I'm going to get the absolute value by itself first in the inequality. So 3z minus 5 is greater than or equal to 8. All I did was subtract 2 from both sides. Now this is the exact same thing as I had up here, except my quantity inside the absolute value is different. But that doesn't change how I do the method. It's still the quantity inside absolute value, 3z minus 5, is either going to be greater than or equal to negative 8, or excuse me, greater than or equal to positive 8, or 3z minus 5 is less than or equal to negative 8. So now I just solve these two inequalities. I'm going to add 5, so 3z is greater than or equal to 13. Divide by 3, so z is greater than or equal to 13 thirds. I'm going to add 5, so 3z is less than or equal to negative 3. Divide by 3, so z is less than or equal to negative 1. Notice how I did not switch my inequality here. As long as you're not dividing or multiplying by the negative number, it doesn't matter if your answer is negative. So now if I have my number line, I'm going to have negative 1 here, and z here is going to be less than or equal to negative 1. So less than or equal means shade to the left. Then I'm going to have 13/3, and it's greater than or equal to, so a closed circle and shade to the right. So I have these two ranges as my solution. Just remember, with absolute value, you're going to have two answers. Okay, for the next part here, we're going to have our cost and revenue. So now we're going to deal with cost and revenue. I want to come up with my cost equations. Now, if you remember from our notes on our cost equations, and if you took a picture in class of the book, you said C of x is just mx plus b. This is our cost equation. Our cost equation is our marginal cost. It's just how much it costs per item, times how many items. So this is for x items. And then our fixed costs here. So for example, I have a problem that says my fixed cost is $2,000. And 36 units cost $8,480. This fixed cost is my B in my equation. This scenario here tells me how to find my M. M is the slope. Slope is a rate of change. So it is the cost per item. So we're going to divide the cost by the number of items to find out how much it costs per item. So we would divide 8480 by 36. Let me get my handy dandy calculator to do that. 8480 divided by 36. And I get 235.56. So this right here is my slope. That is my M value. So now my cost equation is C of x equals 235.56x plus 2,000. So from here you could find out how much it costs to make 1,000 items, how much it costs to make 612 items. You could plug in your x value to get a cost for that amount of items. What I want to find is I want to find the average cost. Because over time, as we make money and start to make money, our cost per item starts to reduce a little bit because we're spreading that cost out over a larger number of items. So we have this formula for average cost. This is the symbol for average cost, is our C of x divided by x. I want to find the average cost for 100 items. That means that I am going to have the average cost of 100 equals C of 100 divided by 100. So for this scenario here, where we have a fixed cost of 2,000 and a marginal cost of 235.56, I'm going to plug in 100 here. So 235.56 times 100 plus 2,000 divided by 100. 235.56 times 100, you just move the decimal place twice. So 23,556 plus 2,000 is 25,556. Divided by 100. So dividing by 100 is where we move the decimal place 2 times to the left. So $255.56. So that's my cost per item. Now, what if I want to find my revenue function? So I have my cost function that's C of x, and then I have a revenue function that's R of x. So if I have, for example, the cost of producing ink cartridges is represented by a cost function of 24x plus 18,000. That means that my marginal cost is 24, so my cost per item is $24 per ink cartridge. That's my cost per item. And my fixed costs are 18,000. Now, revenue is how much I'm making on each item. So what if it tells me that each cartridge is sold for $32. So what would happen here? That means that my revenue function is how much money I'm making off of every item. Well, then I'm making $32 for every ink cartridge that I sell. So I want to find where I would break even. So where my cost, how much I've paid for buildings or labor or anything else, would equal my revenue so that I can start making a profit. So for C of x, I had 24x plus 18,000. For my R of x, I have 32x. What this means is that I am trying to see where my cost function equals my revenue function. So I'm just going to solve this equation for x. So I have 18,000 equals 8x, divide by 8. So for 18,000, gives me 2,250. That means, no, sorry, that's not money. That means that I would have to sell 2,250 ink cartridges. Now, how do I figure out how much money that is? I want to know how much revenue that would produce. So I'm going to plug that into my R function. So I want to know if I sold 2,250 ink cartridges and made $32 off of each one, that means that my revenue for that is $72,000. Now that also means that I spent $72,000 because at the point I've sold 2,250, I am breaking even. My cost would be equal to my revenue. So you can see that here if I plug in 2,250 to my cost. So 24 times 2,250 plus 18,000 also gives me 72,000. So that's where we say we have broken even. Now, that means if I sell even just one more ink cartridge, I've started to make a profit. Remember, your profit is your revenue minus your costs. Okay? What if I have a demand and supply function? So the demand and price of the HBO cable channel are related by this function. So this is the HBO cable channel. This is demand and price. So negative 0.5 Q plus 30.95, where Q is my demand, and P is my price. And we also have a price and supply function of of 0.3 Q plus 2.15. I want to find my equilibrium price and quantity. Well, equilibrium is the exact same thing as my break even, but except we're talking about price and quantities. So I have my equilibrium where these two equations are equal. So I'm just going to plug these in equal to each other and solve for my Q, solve for my quantity. So I'm going to add 0.5 Q to both sides. So I have 30.95. When I add 0.5, I get 0.8 Q plus 2.15. Now subtract 2.15. That gives me 0.8 Q equals 28.80. Now divide by 0.8. So 28.80 divided by 0.8 is 36. That means my quantity at equilibrium is 36 items, or for this example, 36 HBO subscriptions. Now, I would want to know the price at that demand, so I would just need to plug that in, what my equilibrium price would be. So I have 0.3 times 36 plus 2.15. It doesn't matter which one you plug that into. So 0.3 times 36 plus 2.15 is $12.95. So cable companies actually use this price and equilibrium point to determine how much they should charge for those premium packages and things like that, so that they can know how much they should charge to make a profit. Now, we also have our log and exponential rules. You need to know how to manipulate those. I am going to give you a formula chart tomorrow with the algebraic rules for each one of those. But let's practice some problems here. So what if I have log of 4x plus log of 5x to the fifth? If I have adding two logs together, I need to be able to condense those into a single log. So when I'm adding logs, that means I'm going to multiply what's inside. So 4x times 5x to the fifth. So with this, you need to know your exponent rules. 4 times 5 is just 20. X times x to the fifth is just x to the sixth. Remember, same base, you add. So log of 20x to the sixth is that expression condensed. Okay, what if I have something where I'm subtracting? What if I have 3 log b minus 2 log c? These coefficients come inside as exponents, so that means I would have log b cubed minus log of c squared. When I'm subtracting, what I do to condense is I divide. So log of b cubed divided by c squared. And this is condensed. Okay, if I have something where I want to expand, if I have log base 5 of 5z over z minus 2, notice I'm dividing here, so I would separate by subtraction, so log base 5 of 5z minus log base 5 of z minus 2. Now, I'm subtracting inside the log. Notice before I was subtracting two different log terms. So this right here does not separate. But I can separate this 5 times z because I'm multiplying inside the logs. So what I do is I separate that by saying log base 5 of 5 plus log base 5 of z minus log base 5 of z minus 2. Now, log base 5 of 5 is actually something that can be evaluated. Log base 5 of 5 is just 1. So 1 plus log base 5 of z minus log base 5 of z minus 2. So this is fully expanded. All right, now what if I'm going to solve an equation? I have 2 to the 3x equals 1 over 32. I'll do the problem if you have in the book. 64. So what I would want to do here is I would want to convert each side to the same base. Here I have a base 2, so I have 2 to the 3x. But here I have 1 over 2 to the 6th. So that converts to 2 to the negative 6th power. What I do when I have the same base is I just drop those out. So then I have 3x equals negative 6. Divide by 3, so x equals a negative 2. And there's my solution. If I have something like 9 to the 2y plus 1 equals 27 to the y, both of these can be converted to base 3. So this is 3 squared to the 2y plus 1 equals 3 cubed to the y. Now remember, power to a power. This is where your exponent rules would come in. You would need to multiply 2 times this. So this is 3 raised to the 4y plus 2 and 3 to the 3y, because I would distribute that 2 throughout. Now I can drop out my bases and just have 4y plus 2 equals 3y, and subtract 3y and subtract 2, so that y equals a negative 2. All right, what if I have something like 5 raised to the 3r minus 1? That's an r minus 1. Equals 6 to the 3m plus 1. No, that doesn't make sense. Let me choose the right variable. 2r plus 5. Now, 6 and 5 can't be reduced to the same base. So what I have to do is I have to take the log of both sides. When I do that, my 3r minus 1 comes down as a coefficient. So now I have 3r minus 1 times log 5. The same thing here, 2r plus 5 comes down and I have log of 6. Now what I have to do is I have to get my r terms together somehow. So I have to get them on the same side. So this is like saying I have 5 times this. I'm going to distribute this log 5 through that expression. So I'm going to have 3r log 5, 3r times log 5, minus 1 times log 5. Do the same thing with log 6. Now I want everything with an r term on one side and everything without an r on the other side. So 3r log 5 minus 2r log 6. I'm going to add that log 5 to the other side. Now what I want to do is I see that I have an r in both of these terms, so I'm going to factor it out to where I'm left with 3 log 5 minus 2 log 6 equals log 5 plus 5 log 6. Now I can use my log rules to condense and simplify this problem. So I have r. This 3 is going to come up as an exponent, and so is this 2. And I'm subtracting these, so that means I'm going to bring them together and divide. So I'm going to have log of 5 cubed, which is 125, over 6 squared, which is 36. And that's going to be equal to log, I'm adding, so I'm going to multiply 5 times, and this 5 is going to go in as an exponent, so 6 to the 5th. Now, this is just r times something, so to get rid of it, I'm just going to divide it out. Now, I would plug this into my calculator, and what I get when I plug that in my calculator is r equals log of 5 times 6 to the 5th divided by log of 125 over 36. And I get 8.4899. And that's my answer. Okay, let's try an easier log problem. Let's try one that is natural log of m plus 8 plus log of m equals log of 3. Here I need to get single logs together, so I'm going to have the log of m times m plus 8. Since I was adding those exponents, adding those logs, I bring them together to multiply. So now what I have here is a single log term on each side, so I'm going to raise them as powers of the bases. So the e to the log will cancel, and I'm left with m times m plus 8 equals 3. So now I'm just going to distribute m squared plus 8m equals 3. Move the 3 over. Now what happens here is I need to use quadratic formula. Quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a. So I have negative 8 plus or minus b squared minus 4 times a times c all over 2a. So that's negative 8. This is 64 plus 12, so that's going to be 76 over 2. Now 76 is divisible by 4, so I'm going to simplify the square root of 76 to be, that's 4 times 19. So I'm going to simplify that to be 2 square roots of 19 over 2. Now notice here each one of these can be reduced by a factor of 2. So I'm going to have negative 4 plus or minus square root of 19. And that's it. That's my answers. Okay. What if I have log of x cubed equals 2? I already have my single terms on each side, so what I do is I raise both sides as a power of my base, so that 10 log 10 will cancel and I'm left with x cubed, but this is now 10 squared, which equals 100. So now I have to figure out what x cubed will give me 100. To get rid of the cube, I just cube root both sides, which is taking each power to the 1/3. So 100 raised to the 1/3 is 4.642. And that's my answer. Okay, now we're going to look at some of the problems from your packet that I gave you, actually. The Chapter 5 review exercises. You have the formulas for each one of these. So we're going to look first at simple interest. So simple interest is I equals PRT. We also have our future value for simple interest, A equals P times 1 plus RT. Our present value is A divided by 1 plus RT. All right, so now what if I have a problem that says find the interest, so I, for $49.02 at 6.5% interest rate for 11 months. That means I'm going to find the interest, so I'm going to use I equals PRT. This is my principal, this is my R, but I need to write it as 0.065, and this is my T, but I need to convert it to years, so that's going to be 11 over 12. So I is 4902 times 0.065 times 11 over 12. So 4902 times 0.065 times 11 over 12. And I get 292.08. What if I wanted the future value of this account? I could just add my principal and interest together, because another thing for A is just A equals P plus I. Or I could plug that in. So let's do this first. Let's say plus 4902 is 5194.08. Now let's plug this into our value formula here and see if we get the same A. So A equals P times 1 plus RT. So my principal is 4902 times 1 plus 0.065 times T, which is 11 over 12. So I have 4902 times 1 plus 0.065 times 11 over 12. And I get 5194.08. So you can do those either way. To find present value, all I have to do is, instead of solving for A, I'm solving for P, so I would just divide. Make sure when you put those in the calculator that you put parentheses around that denominator. Okay, what if I want to find compound interest? Compound interest is where we have a certain time period and we are compounding as however many times per year. So if I have this formula, the I is equal to my rate divided by my M. N is M times T. R is my interest rate. M is the number of times per year. The interest is compounded. And T is time in years. So, for example, if I want to find the compounded interest amount for $2,800 at 6% compounded annually for 12 years. I'm going to have an I of 0.06 divided by 1, because annually means my M value is 1, and an N of 12. So 2,800 times 1 plus 0.06 to the 12th. So 2,800 times 1.06 raised to the 12th power is 5634.15. Okay, so that is my future value, so my A, for compound interest. What if I want to find the present value? That means I'm then going to divide my A by 1 plus I over N. Alright, make sure you understand your annuity formulas. When you have an ordinary annuity, we have an ordinary annuity is one where we get payments at the end of each period. An annuity due is where we have payments or R values at the beginning of each period. So I want to find a future value of an annuity. So I have 1288 deposited at the end of each year for 14 years at 7% compounded annually. If you look in your practice problems, this is number 32, finding the future value of an annuity. So future value is S equals R times 1 plus I to the N minus 1 over I. Remember, I is still R over M, and N is still M times T. Here, my I is 0.07. M is 1. Now, what if I have my N value is going to be 14. My R value is my initial deposits every year. So I'm going to plug this in. S equals 1288 times 1 plus 0.07 raised to the 14th power minus 1 over 0.07. Make sure when you put this in the calculator that you put that numerator in parentheses, and go ahead and put the denominator in parentheses. Just get used to doing that. So I have 1288 times 1.07 raised to the 14th power minus 1 divided by 0.07. And I get $29,045.03. Okay. What if my question is asking for find the amount of each payment? That is solving for my R value. So what if I now have, this is number 39, $57,000, 6% compounded semi-annually, for 8.5 years. So this is my R, this is my T, which is really 8.5, this is really 0.06. Semi-annually means I have an M value of 2, and this is my R value. Oh, I'm sorry, not my R. This is my S value, excuse me. This is my maturity value. I'm wanting to solve for my payments. So I have S equals R times 1 plus I to the n minus 1 over I. So S is 57,000. I'm solving for R, and I'm going to have 1 plus 0.06 over 2 raised to the m times t, so 8.5 times 2 is 17, minus 1 over 0.06 over 2. Now for this one, it'll be easier for you to go ahead and calculate. 0.06 over 2 is really 0.03, so that's my I value. So when I put this in the calculator, I'm going to be dividing 57,000 by this entire fraction, which is really 1.03 to the 17th minus 1 over 0.03. You need to make sure, though, to put this in parentheses and that entire fraction in parentheses. So when I divide this, I get 57,000 divided by 1.03 raised to the 17th minus 1, close parentheses and divide, by 0.03. And I get 2619.29. So that is my R value, my amount of payments that it would take to be able to accrue to 57,000 after 8.5 years. Now, finding the present value works the same way. For annuity due are the same way, they're just different formulas. Really, the only thing that you need to worry about is being able to pick out what the values are and being able to put these in the calculator. Make sure that you're using the correct amount of parentheses and you'll be just fine on these.